Welcome to Math World. I have discussed polar form of a complex number in my last video. In this video, I'm going to introduce the second alternate form of a complex number, that is exponential form of a complex number. For that, we need Euler's formula, that is e power I theta is equal to cos theta plus I sin theta. E power I theta is nothing but cos theta plus I sin theta. This is the Euler form. With this, we can rewrite the polar form of a complex number into its exponential form. That is, say, we studied rectangular form. I repeat, that is z equal to x plus iy. This is same as Cartesian form of a complex number, and we can even rewrite this in the polar form, that is z equal to r into cos theta plus I sin theta, or r into cis theta, where theta is tan inverse of y by x, which is nothing but argument of z. So this we have learned. Now the exponential form using this. So this cos theta plus I sin theta, I am replacing it by e power I theta. So this is the exponential form of a complex number, that is z equal to r into e power I theta. Okay, where theta is nothing but argument of z. Similar to polar form, there are infinite number of possible exponential forms for a given complex number, because we are getting different values for argument of z. So this, even in general, even this can be written like this: z equal to r e power I into theta plus 2n pi. Okay, where n can be 0, plus or minus 1, plus or minus 2, like that. Okay, this is the general form of a complex number in exponential form. Now, if any such number is given, how to calculate the value of r? It's quite easy. See, again, z is r e power I theta, and modulus of z is nothing but modulus of r e power I theta, which is same as writing mod r into modulus of e power I theta. Then this is same as writing modulus of r, that is root of r square. I hope you know this. And then this is e power I theta is nothing but cos theta plus I sin theta. Its modulus I have to calculate. So which is same as writing modulus of z equal to root of r square into root of cos square theta plus sin square theta, which is nothing but modulus of cos theta plus I sin theta. This is 1, so root of r square into root of 1, so it's 1, so root r square is nothing but r. So modulus of z is simply r. So even if the complex number is written r e power I theta, modulus of z is same as r. Okay. Note that the z equal to r into cis theta, which we write it as a polar form, is a parametric representation of a circle of radius r, right? So since this is a parametric form of a circle, even r e power I theta, r into e power I theta, this is also a parametric representation of a circle whose radius is r and say center is at origin. Okay. As the parameter theta increases from 0 to 2 pi, the point z starts from the positive real axis and it traverses the circle once in counterclockwise direction. So suppose okay, this is x-axis, y-axis, imaginary axis. Say this theta, it's initially at 0, from positive real axis if it travels like this, say somewhere here, suppose this is my z, r e power I theta, this is theta. Okay. So as theta increases from 0 to 2 pi, the point z, this is z, starts from positive real axis and traverses the circle once in a counterclockwise direction. In general, the circle say modulus of z minus z naught equal to r, whose center is at origin and whose radius is r, has the parametric equation say z equal to z naught. Says if the center is not at origin, in that case we write it like this: z equal to z naught plus r e power I theta, where this theta lies in between 0 and 2 pi. Vectorically you can represent it like this. Suppose center is not at origin, at some point z naught, say this is z naught, so this is z naught. Now this is the center, then we have taking this as axis and say this is the angle, z is somewhere here and this is the angle it's making, theta. I can say r e power I theta. This as a center we have to draw a circle. Okay, I'm not that good at drawing. Okay, this is, assume that this is a circle and say this is the point, this is a complex number z. Okay, this z naught is at center, this is z naught and this is r e power I theta. Okay, so this is z naught and this is z. This was at origin, now it is shifted to z naught. In that case z is nothing but, this is z is nothing but z naught plus r e power I theta. This part is r e power I theta. Okay, now that we have got the exponential form, let us use this along with the basic exponent properties to derive some nice facts about complex number. The first one is products in exponential form. What happens to product of two complex numbers if we have written them in exponential form? Products in exponential form. Say suppose z1 is r1 e power I theta 1 and z2 is r2 e power I theta 2. Okay, what happens to z1, z2? So multiply them. r1 e power I theta 1 into r2 e power I theta 2. So r1 r2 See, this is r1 into cos theta 1 plus I sin theta 1. So I'll write that first. r1 into cos theta 1 plus I sin theta 1. This into r2 into cos theta 2 plus I sin theta 2. Okay, multiply r1 r2 together. I'll keep it outside. Then cos theta 1 into cos theta 2, 1 into cos theta 2 plus cos theta 1 into I sin theta 2, cos theta 1 into I sin theta 2 plus, multiply this with this, I sin theta 1 into cos theta 2 plus I sin theta 1 into I sin theta 2, that is I square sin theta 1 into sin theta 2. Okay, now thus I square is minus 1, right? So cos theta 1 into cos theta 2 minus sin theta 1 into sin theta 2. That's nothing but cos of theta 1 plus theta. So cos theta 1 into cos theta 2 minus sin theta 1 into sin theta 2 is nothing but cos of theta 1 plus theta 2. And similarly, cos theta 1 sin theta 2 plus sin theta 1 cos theta 2 is nothing but sin of theta 1 plus theta 2. So I'm just replacing them. Cos of theta 1 plus theta 2 plus I into sin of theta 1 plus theta 2. So cos of a plus b and sin of a plus b. Okay, so this is same as writing r1 into r2 into e power I theta 1 plus theta 2. E power I theta is cos theta plus I sin theta. In place of theta we have theta 1 plus theta 2. So z1 into z2 is r1 into r2 into e power I into theta 1 plus theta 2. Now let us see what happens to z1 by z2. z1 by z2, that's r1 e power I theta 1 divided by r2 into e power I theta 2. What I do is, for this I'll just multiply and divide by conjugate of the denominator, that's e power minus I theta 2 divided by e power minus I theta 2. So this will be r1 by r2, r1 by r2 into, this is e power I into theta 1 minus theta 2 divided by e power I into theta 2 minus theta 2, that's 0. Okay, e power I into 0. I into 0 is e power 0, that's 1. So the remaining is r1 by r2 into e power I into theta 1 minus theta 2. So this is z1 by z2. Now what happens if the complex number is expressed in exponential form? What happens to its inverse? How is the inverse? That's if z equal to r e power I theta, which is a non-zero complex number, then its inverse is z inverse, and that is 1 by z, which is nothing but 1 by r e power I theta, which is same as writing 1 by r into e power minus I theta. In fact, you can even write it as 1 by r into cos of minus theta plus I sine of minus theta. Cis of minus theta, 1 by r, that you should remember. Okay. Okay, now what happens to power of z? That is, say, z power n. In my last video, I have taken one complex number and its power is 7. You have to write that in Cartesian form and all. So that was the problem. So same way, how to solve that I'm going to teach here. Okay. Say z power n equal to r power n into e power I n theta. See, this we can prove by mathematical induction by taking different values for n. Okay, so I'm not going to prove it, I'm just mentioning it. When you have z equal to r e power I theta, then when n equal to 1, it becomes r e power I theta. When n equal to 2, it's r square into e power 2 I theta. Like that, when n is equal to m, it's r power m e power I m theta. Okay, so this is, in fact, we can write, see what happens is, from de Moivre's theorem, in fact it's a formula. Okay, what he says is, when we have cos theta plus I sine theta, when it has got power n, then this is same as writing cos n theta plus I sine n theta. Okay, this is the formula. Now what I do is, I'll just replace this with e power I theta whole power n, and this must be equal to e power I n theta. Okay, so same thing I'm applying over here and I'm saying thus. Okay, so now come to that problem. Write the complex number root 3 plus I whole power 7 in rectangular form. Okay, now directly going for this is quite difficult. Okay, for that sake we rewrite this complex number in terms of exponential form. Okay, so now let me take this as z. Let z is simply root 3 plus I. Okay, when that is the case, r is root of 3 plus 1, that's 4, which is equal to 2, and theta equal to tan inverse of y by x, so 1 by root 3, it is pi by 6. Okay, now z power n, this is 7 here, z power 7, that is 2e I e to the power I pi by 6, e power I theta, I'm writing it in that form. Okay, exponential form, it's power 7. This I have to simplify. Okay, so z power 7 is equal to 2 power 7 into e power I into, see, e power I theta whole power n, that is 7 here, so it will be e power I 7 theta. Theta is pi by 6. Now this I can rewrite, in fact, as 2 power 6 into e power I 6 pi by 6 into 2 into e power I'm sorry, e power I pi by 6. Okay, now This will be C. This I can cancel. Okay, so it is 2 power 6 into e power I pi. Right. Now what is this? This is nothing but z, right? We have taken z as root 3 plus I, which is nothing but 2 into cos pi by 6 plus I sin pi by 6. In fact, it is 2 into e power. If you want, I can rewrite this in exponential form. That will be r into e power I theta. Theta is pi by 6. So this is the exponential form for z equal to root 3 plus I. So this I can replace it by root 3 plus I. Okay, now what is e power I pi? E power I pi is cos pi plus I sin pi, which is nothing but minus 1, right? Because sin pi is 0 and cos pi is minus 1. So z power 7 is nothing but 2 power 6 into minus 1 into root 3 plus I. It's nothing but minus 64 into root 3 plus I. Got the point? So I have rewritten root 3 plus I whole power 7 into minus 64 into root 3 plus I. This is the rectangular form of a complex number root 3 plus I power 7. Okay, now that's all in this video. In my next video, I'm going to discuss about few factors with the argument of z. What happens to product of arguments and what happens to their quotients and all. Okay. Thank you for watching.